Well, welcome to this afternoon's plenary session here at the conference. I'm Dr. Andrew Snelling. I'm a geologist who works at Answers in Genesis. And this afternoon we're going to do a broad overview of this question, dating the Earth young or old. This is perhaps the central issue or question that people get heated over in this origins debate. You know, because once you start talking about the Earth being young, then you're talking about what the Bible's saying about the age of the Earth, and you're also not allowing enough time for evolution to have occurred. And so this is the most hotly debated topic. I don't have time this afternoon to delve into every aspect. A lot of it will be skimming the surface, but I want to show you some of the array of information that is available to you and how we reason through the information that's available. So with that, I want to launch into it. And first of all, I want to emphasise, no matter how we answer this question from a scientific perspective, that all scientific evidence for the age of the Earth is based on unprovable assumptions. That's so important. Why? Because we weren't there in the past. We only have the present to study, and we're looking at the details in the present and extrapolating them back in the past. So what we do, whether we're trying to prove a young or an old Earth, we start with a process that we know its rate in the present. We can measure that process. So we can measure how much sediment is going down into the oceans every year down the rivers. We can measure the Earth's magnetic field and what's happening to it today. We can look at comets, and we're going to come to some of those issues. And then we have some suitable and reasonable starting conditions, but we have to assume those because we weren't there when the process started. And so we're stuck with just the measurements in the present, but we have to assume some reason. Now, if you're starting from a naturalistic assumption, then you're going to have the processes starting in a different way. Some other starting conditions, but of course when we come as creationists we have a different set of starting conditions, and you'll see that more as we delve into it. But we have to assume, or we can assume, that the process rate has remained constant since the process started at the rate we measure today. That's the assumption that most secularists would assume. That is, that present-day processes and their rates are all that are necessary to explain what happened in the past. It's the view that's often called uniformitarianism. It doesn't rule out occasional catastrophes. Modern secularists posit things like meteorite impacts that wiped out the dinosaurs. Well, we don't experience a meteorite impact of that scale today, so that is allowing for some catastrophic processes in the past. But generally, they'll assume that rates have been constant through the past, but that will only ever give us a maximum qualitative age for the Earth. We have to always recognise that no matter what process we choose, whether we're trying to demonstrate a young or an old Earth, we're always making assumptions. That's for every one of us in this room. And it's very important to recognise your assumptions because, and their limitations, because that means you're more tentative about your statements from your scientific results. With that said, these are some of the examples of some of the processes that have been used to date the Earth and the solar system and the universe that have been used. And we're going to look at some of these this afternoon. And it's true that about 90% of them yield a young age for the Earth and only about 10% yield an old age. Some are more reliable than others, and we want to delve into those this afternoon. So let's look at some of these processes. For example, short period comets. And Danny Faulkner, I owe him credit for some of this information. But you're familiar with comets. Comets consist of ice and dust, and so they're essentially dirty snowballs. And as they come through so here we can see the head, and here's the tails. You see there's two tails. There's a gas tail and a dust tail. As a comet comes close to the sun in its elliptical orbit through the solar system, You have the solar wind, which is particles that are streaming out from the sun. They interact with the head of the comet, and you get the gas and the dust blown off and stream back. And so that's the tail, which is illuminated by the sunlight as it gets closer to the sun. And so what's happening is the comet is actually disintegrating because it's losing some of those ice and dust particles in its nucleus. And unlike planets, they go through elliptical orbits. The short period comets are defined as comets with an elliptical orbit period of less than 200 years. And so one of the familiar ones is Halley's Comet, which returns every 70 to 80 years. And of course, we all know from historical records that it was a more spectacular display in the past, simply because it was larger. It had more material streaming off, and so it was brighter. As it's come on later passes by the Earth, it's less spectacular, and that's because it's disintegrating. It's slowly wearing out. And so, as I said, as it goes past the sun, it's losing some of its dust and ice, and so over time, these comets are eventually destroyed or completely disintegrate. Sometimes, of course, we've seen with the Levy-Shoemaker comet some years ago, it got too close to Jupiter and it actually broke apart and slammed into Jupiter. So these comets, the main message here is these short period comets are disintegrating, they're destroyed. So the question is, where did the comets come from? If they only last, if they have a period of only 200 years and they're disintegrating, then in time they're going to disappear, but we've still got comets in the solar system today. Then where are they coming from? And there's been two suggestions that there's been the short period comets have come from the Kuiper belt, and then there's the longer period comets that have come from the Oort cloud. And here we can see, here's the inner part of the solar system. You can see that the Kuiper belt is supposed to be in the outer parts of the solar system, and then this Oort cloud is way out there beyond the solar system. Now, the question is, does the Oort cloud exist? And this is a quote from Carl Sagan, no less, that many scientific papers are written each year about the Oort cloud, its properties, its origin, its evolution, yet there is not a shred of direct evidence for its existence. It's basically a hypothetical construct out there. It may well be out there, but it's not been observed. We don't have the evidence for it. But it certainly helps the long age people to explain the origin of these comets, these long period comets, which are greater than 200-year periods, because we've got a source out there. They believe that they might have a source of the short period comets, like Halley's Comet, from the Kuiper belt. We certainly have observed trans-Newtonian objects. Now, depending on whether you like it or not, you know, Pluto was actually downgraded to a trans-Newtonian object. And so it, in a sense, populates part of this Kuiper belt, which was discovered in 1930, the trans-Newtonian objects, and has been re-emphasised with more and more discoveries in the past 20 years. You know, as we've been able to put up satellites with telescopes on them that get out of the Earth's atmosphere, you can see things more in sharper view out there in space because you're not looking through the Earth's atmosphere. So more and more of these have been discovered. Some of these have been called Kuiper belt objects, but the problem is that they are too large in size to be the source of the short period comets, and the composition isn't right. So in other words, the Kuiper belt doesn't help the astronomers explain the short period comets. So they're left with a dilemma. Where do these short period comets come from? Everyone agrees that they're supposed to have been there since the origin of the solar system. So that's not an issue. But the evolutionists claim the solar system has been here for 4.5 billion years. So the comets should also be of similar age. Yet, we can determine how quickly these comets disintegrate, assuming they've always disintegrated at the same rate that we observe today. Then the short period comets may likely only last less than 10,000 years. So if they date back to the origin of the solar system, then the short period comets are not 4.5 billion years old or so. They're probably less than 10,000 years, which dates the solar system, which dates the Earth. And so you can see the line of argument. And so this is a reasonable indication that the solar system and the Earth may be young, less than 10,000 years old. So, as I said, evolution argued that new short-period comets come from the Kuiper Belt to replace those that disintegrate, but we have not seen any. So, without a source of new short-period comets, the fact is we still see them in the solar system. That means the solar system is less than 10,000 years old, and the Earth as well. Now, the Earth has a magnetic field. And by the way, I've chosen examples that are very important. You notice these are examples of large-scale processes. The first example was a solar system-wide process. Now we're dealing with a process that Earth-wide. Later on we'll talk about, and we'll have a whole session on radiometric dating of rocks. Well, that's just a local rock sample in one little part of the Earth. It's not a big picture evidence, and we need to keep that in mind. Now, the Earth's magnetic field, which appears to be generated in the Earth's core as a result of motion in the Earth's core, it's generated by electrical currents. This goes back to the work by Thomas Barnes that was built on by Russ Humphreys. But in the outer core, the inner core is solid, the outer core is fluid. And so you get movement of material, you've got electrical currents there. Electrical currents, as you know from your physics, will generate magnetic fields. And if you change the direction of the electric current, it will change the direction of the resultant magnetic field. What we've discovered from real-time measurements that the energy of the Earth's magnetic field loses half its energy in approximately every 1,400 years. We know that from historic measurements. As early as the early 1800s, there were measurements that have been made. And we can see on this graph that the energy of the magnetic field, it indicates that it has been decreasing at a steady rate. Now, this is the strength of the energy of the field, not just simply the strength, the energy of the field. Now, during the flood, here again now see we've introduced another component. We're assuming that during the flood, things might have been happening at a more catastrophic rate. And certainly, during the flood, because of the catastrophic activity, the Earth's magnetic field would have lost its energy much faster during the flood because, as the geologists know from this morning's session, there were things happening on a catastrophic rate inside the Earth that resulted in catastrophic processes on the Earth's surface with plates moving around and colliding, sediments moving around, and you'll hear more about that in the geology sessions to come. So if we go back in time, we know that there were reversals of the Earth's magnetic field during and after the flood. We can actually find evidence of the strength of the Earth's magnetic field even in in pottery and archaeological sites where the clay is baked. Sometimes you get the magnetic minerals in the clay that gets baked, and when it gets baked, if it's hot enough, it will lock in the direction of the Earth's magnetic field and virtually fossilise measurements of the Earth's magnetic field at the time. And so we can get some feel for the intensity and the magnetic directions in the past, even going back into earlier periods. We can also see evidence of magnetic reversals recorded in the ocean floor basalts that erupted during the flood. Dr. Kurt Wise and Dr. Steve Austin talked about that in the geology session this morning. Some of you may be familiar with that information, evidence of the magnetism was locked into the basalts when they cooled. And in fact, we've seen evidence of these reversals having been rapid. Why? Lava flows on Steens Mountain in Oregon, southern Oregon. We know we can actually work out how long it takes a lava flow to cool. And if you get one that's thin enough, it will cool down to the temperature at which the magnetic field direction will get locked in. It will cool to that in a matter of a week or two. And so we actually, in the 1990s, geophysicists working on those basalt flows in Oregon actually found the evidence where parts of a reversal were recorded in these lava flows that cooled in less than 2 weeks, indicating that it was very rapid. The geophysicists, conventional geophysicists, who had a different model for the Earth's magnetic field, were scratching their heads because according to their model, their dynamo model, it would take hundreds of thousands of years for these reversals to occur. But in the context of a creationist flood model, where it's electrical currents and you're getting the movement of fluids inside the inner core during the flood, electrical currents change direction, change the magnetic field very quickly. It can cope with this happening in just a short period of time, in days to weeks. Interestingly, some of you may not be aware, but this has also been confirmed from lake sediments in the Apennines of Italy. There was a paper just about 2 or 3 years ago in one of the journals, Geophysical Research Letters, where they reported on these lake sediments not far northeast of Rome, where they also found evidence of a part of a reversal recorded in the sediments that had been deposited very rapidly. So we have confirmation that these changes of magnetic field direction contain very rapidly, and as I said, we can see it from recorded in ancient pottery. So if we extrapolate that rapid field energy loss back into the Earth's history, taking into account the fact that the flood will cause some major disruptions, then you can see the further back you go, you get a stronger and stronger magnetic field. It gets so strong that it becomes intolerable for life on the Earth. And so that puts an upper limit. And that upper limit then comes down to about a maximum age of 10,000 years. Again, this is a whole Earth process. Now, we're making a lot of assumptions. And I emphasise that, because no matter how we do our science, when we're dealing with the past, we're making assumptions. What about the erosion of continents? Every year so many sediments get washed by rivers down to the oceans and they end up down on the ocean floor. We can measure the rate of erosion of the continents today. And assuming the past erosion has always been at today's rate, then all the continents would have been eroded to sea level in no more than 14 million years. Now, of course, people will argue, well, as you erode material off, the continents get lighter and so they'll rise, and so you'll keep elevating your land surface. Yeah, there's a lot of caveats, for sure. But here's the problem. If 14 million years, if you did that erosion, why do we still have mountains today? Why are the Appalachians still there if they've been eroding as they have been for 300 million years? But you see, we have to ask the question, go back and question our assumptions. The conventional wisdom is the rate has been more or less the same through all the millions of years. But has past erosion been always at the same rate today? No, because erosion rates were extremely catastrophic at the end of and soon after the flood, with the waters retreating off the land surface, as Dr. Austin indicated, a rapid rise of vertical rises at the end of the flood. We see lots of evidence for that. Then the erosion is going to be extreme. So most of the erosion of the continents would have occurred in only a few thousand years. And so that means that we have to drastically reduce that 14 million year estimate. So in other words, we can take that, and by plugging in our assumptions based on the flood producing most of those sediments, then that number, 14 million years, comes right down and gives a much, much younger age. The same with the sediments on the seafloor. We can measure the average thickness of the loose sediments on the seafloor. We can figure out how much mud is entering every year, how much mud is coming out, because some leaves as it goes down into these ocean trenches and gets pushed down into the mantle. But you can do the math and figure out the mass balance between different materials. And so if the past accumulation rate is similar today, then all the sediments on the seafloor would have probably got there in about only 12 million years. But that's vastly shorter than the seculist conventional time frame. And now let's plug in our own assumptions. Has the past accumulation rate always been the same as today? No. As we said, during the flood, particularly at the end of the flood and soon after, we had catastrophic erosion as the land surface was rising, the floodwaters retreating, carving out canyons. Most of those sediments on the ocean floor would have been put there in just a few years at the very most. And so that drastically reduces that estimate for the accumulation of the seafloor sediments from 12 million years down to, just a few thousand years since the flood. What about the saltiness of and again, these are total Earth processes, okay? We're talking about global scale processes, the saltiness of seawater. We can do the math and the mass balance, and Dr. Steve Austin did this work years ago with Russ Humphries. They teamed up, and so this is available as a scientific paper if you want to go into the more details. A lot of this material is available in detail in the creationist technical literature, and so we can quantify all these different parts of this sequence, and just taking sodium as one of the components of materials that get washed into the ocean. Sodium, of course, is the component of common salt, sodium chloride, and we can figure on something like 450 million tonnes per year going in and 120 million tonnes per year going out. This is a result of sea spray coming up on the land, etc., etc. And so we can measure today's rate of the salt entering the oceans. We know how salty the ocean water is today. If we start with freshwater oceans, that's our assumed starting conditions, then if the present level of saltiness of seawater would have been reached in only just about 62 million years. As Dr. Steve Austin indicated, and Russ Humphries, that's being very generous to the conventional paradigm, 62 million years. Yet, everyone agrees in the conventional community the oceans have been around for at least 3 to 4 billion years. I say 4 billion years now because in the literature there's more and more evidence that the oceans were formed very early in the Earth's history, according to the conventional paradigm. So here's disjointed figures, aren't they? They get the saltiness starting with a freshwater ocean at the present rate of adding salt to the oceans in only 62 million years, but the oceans have been around for 3 to 4 billion years. Well, they have to try and reconcile that, but there's been no way that they can do that. We have to ask ourselves from our paradigm, from a biblical worldview, would God have started with freshwater oceans? Well, maybe not. He certainly created fish that could tolerate a salty ocean. So maybe he started with fish in a salty ocean, maybe not as salty as today. We don't know because we weren't back there. But we do know the oceans got saltier in the past. And has the salt always entered at the rate we measure today? No. Humongous amounts of salt were added to the oceans catastrophically during the flood. From all that volcanic water that was released from all that explosive volcanic action. I mean, 70% of what comes out of a volcano is water. And it's got all chemicals in it. It's hot. And of course, so the eroding sediments, just like erosion today releases chemicals into river waters, well, so during the erosion during the flood. So that means that was a massive amount of addition of salt to the oceans during the flood. So if we don't start with salty ocean, if we start with salty oceans rather than a freshwater ocean, and we add all the salt during the flood, then the present level of saltiness would have got there very, very rapidly. And so it would have been achieved in only thousands of years. So you can see what I mean when you look at the assumptions of the starting conditions, the assumptions of the rate, depending on your paradigm, whether you're old Earth or young Earth, you're going to plug in different assumptions and different starting conditions, and you'll get different results. And we can definitely show from a biblical perspective that the oceans are therefore very young, and if the oceans are very young and go back to the early history of the Earth, and in fact the Bible says God created the Earth, it was already covered in water right from the beginning, then it indicates a young Earth. Helium in the atmosphere is another indicator. Helium is a byproduct of radioactive decay, and we'll come back to that later in the conference. It leaks out of rocks and minerals and eventually finds its way into the atmosphere. We can actually measure the rate of helium addition to the atmosphere every year. But we do know that some of that helium leaks out into space. There's no question about that. There's increasing evidence that that's the case. It's not fully quantified, but it's certainly not as massive amount as what's coming out of the rocks, out of the ground. And so if we measure the rate at which it leaks into the atmosphere today, we do the math on also on how much leaks out of the atmosphere into space. And if we assume a helium-free atmosphere initially and the leakage of helium at today's rate, then all the helium in the atmosphere would have got there in less than 2 million years. So that kind of dates the atmosphere, which is a global scale thing. Therefore, it's an indicator of the age of the Earth. But the atmosphere has been claimed to, by the conventional paradigm, to have been there for at least 3 to 4 billion years. So without an extra source of helium or a greater past leakage into outer space, the atmosphere is less than 2 million years old. But again, if the Earth's atmosphere had some helium to begin with, and if radioactive decay was much faster during the flood, which I'll illustrate when we talk about radiometric dating tomorrow, then additional helium would have leaked in the atmosphere, and only all the helium would have leaked in only a few thousand years, and so the atmosphere is only as old as all that. So again, that's a global scale process that limits the age of the system. Another indicator, what about the Stone Age graves? Here's the argument. According to the conventional paradigm, the man was in the Stone Age for 195,000 years. And during that time, it's estimated the population would have averaged around 1 million people throughout that 195,000 years. Well, that means during that time period, about 8 billion people will have lived and died. So where are all their graves? How come we find so few of these human remains in post-flood sediments, people that lived after the flood, people that said that have lived in the Stone Age? If the Stone Age was 195,000 years long, there would have been about 8 billion people that lived in that time, but we find so few graves, so maybe the Stone Age wasn't 195,000 years long. Maybe it was just a brief technological transition from the people who left the Tower of Babel only about 4,300 years ago. After all, when they left the Tower of Babel, a lot of them had to leave the technology behind, so as they moved out, they just grabbed what they could to start clearing forests and lighting fires and starting to re-establish technology in their lifestyle again. Only a brief period. What about the advent of agriculture? We know when that happened. It's only not that long ago, less than 10,000 years ago. As I said, evolutionists, the conventional paradigm claims that man have been hunter-gatherers for, those 195,000 years through the Stone Age, and they only discovered agriculture less than 10,000 years ago. But it begs the question, if there were 8 billion people that lived during that time as hunter-gatherers, how come one of them wasn't smart enough to figure out if you put a seed in the ground, you could grow crops? Now, come on. I mean, that was an obvious observation. And so why did it take them so long to discover agriculture? Well, probably because it wasn't that long time of a period. In fact, the Bible tells us that Noah, when he got off the ark, planted a vineyard. They knew about agriculture because they had agriculture in the pre-flood world. So agriculture was immediately re-established after the flood, and the Stone Age, as I said, was only a mere brief technological transition. It wasn't that people were less intelligent, it was just their technology, because they had to re-establish it after they were dispersed dramatically and catastrophically at the Tower of Babel. And so if the advent of agriculture is less than 10,000 years old, that dates back to the time of Noah. And again, it's a limitation on human history and therefore the Earth's history. What about the length of written history? Man has always kept documents written on monuments, cave paintings, all the rest of it, and it's only been around for about 5,000 years. He's always been intelligent. Beautiful cave paintings, even records of lunar phases. The more we investigate some of these sites like Stonehenge and some of these other sites, they were actually astronomical observatories. You know, you go to Machu Picchu, and, you know, they had the sundials set up. They were wanting to know when to plant crops and everything. These were not unintelligent people, and they kept records of these phases so they could know when to plant their crops. And so, again, why did man supposedly wait 195,000 years to suddenly invent writing skills? No, it doesn't make any sense at all. Adam communicated with God in the Garden of Eden. The ark was built under God's direction. And written records go back 5,000 years, therefore human history back to the flood goes back about that time. Human population growth is another indicator. If we assume about 4.5 years from Noah to the present, and conservatively assume a generation span of 40 years and 2.5 children per family, we'd get the resultant 7 billion people today on the planet in that time period with a growth rate of only about 0.5%. Whereas the current average is about 3.5 children per family, a growth rate of about 2%. And this would have been greater in the past because they had larger families. Okay, mortality was higher, lifespans were slightly shorter. But if we plug in those figures, in 4,500 years we'd get many more than the 7 billion people that we have on the planet today. That allows for those who died early from disease or wars. And so the evolutionists claim that you know, man has been around for at least half a million years. But you know, if that were true, there ought to be so many people now on the Earth's surface, you know, we wouldn't be able to fit them in. And so again, the human population growth puts limits on the age of the human population, how long we've been here on the Earth since the time of Noah. So all of these methods, some of these that I've highlighted here, we can yield a young age for the Earth and the solar system. But what about some of these 10%? You know, the one that the conventional paradigm always focuses on is radiometric dating. And is it a reasonable approach to look at the 10%? And not focus on the 9%, 90%. Well, let's have a look at how the evolutionists conventional claim that the Earth is just over 4.5 billion years old. They used radioactive dating of rocks. No, they didn't. Did you realise that? The age of the Earth was not determined on Earth rocks. It was determined by using a group of meteorites. Back in 1956, Claire Patterson at Caltech used meteorites to date the age of the Earth. The assumption was that the meteorites came from asteroids that formed at the same time as the Earth from the solar nebula. The meteorites thus represent the Earth when it's formed, and it assumes that radioactive dating actually works. And so they're the assumptions that were made in acquiring the age of the Earth. Well, how does radioactive dating work? I'm going to come back to this tomorrow in more detail, but let's do a quick thumbnail sketch. The process is similar to what we see with an hourglass clock. We have parent atoms here that fall and become daughter atoms. We know the rate of falling, which is like radioactive decay. So if you've got an hourglass clock that's rated at 1 hour, all the sand grains fall from top to bottom in 1 hour. if you walk into a room and you see half the sand grains up the top and half the sand grains down the bottom, how long has the clock been ticking? Half an hour. Oh, that's assuming that you started with all the sand grains up there, which is a point to come to. But how does it work? Well, a rock is chemically tested for these parent and daughter atoms. And if you know the rate of decay and you assume that it remains constant at today's measured rate, then you can calculate backwards by measuring how many green atoms you've got here. If they all came from red atoms, you can calculate, if you know the rate of falling, you can calculate how long ago all the green atoms were red atoms up there. And you just did that. When I said if half were down here and half were up there, you immediately knew that if half would come down from there at the rate of falling, 1 hour, half an hour. It's the same in the rocks. By measuring the daughter atoms, assuming they all came from red atoms, you know the rate of falling or radioactive decay, you can back calculate, and that's the age of the rock. Assuming what? Well, you have to assume that all the sand grains in the top bowl, the red atoms, fell down. They didn't start with any red atoms to begin with. Any green atoms to begin with, okay? If the rate of radioactive decay has remained constant, the falling rate, then you can calculate how long the hourglass has been operating. So as I said, there's three major assumptions. So the use of the hourglass requires three crucial assumptions: the starting conditions, a closed system, and a constant falling rate. So these three assumptions are even more crucial to radioactive dating methods. But here's the difference. When you play with an hourglass, you're there to see the starting conditions, with a geologist there to see the rocks when they form. Assumption number one, you have to know the initial conditions. You have to know that the amounts of the parent and daughter atoms at the beginning when the rock formed. Okay? And the geologists believe that they can make reasonable assumptions. The assumption is that when the rock forms, that's when the clock starts ticking. But were there only red atoms in the rock? Were there green atoms as well? They don't know. They have to look from the present measurements of these quantities in the rocks and try and infer what it was back in the past. And that runs into problems, as I'll show you in a moment. You have to assume that all the daughter atoms, the green atoms, have come from radioactive decay of the red atoms. That there's been no red atoms added or green atoms taken away. What if the system hasn't been closed? In your hourglass clock, everything's sealed nicely so that there's been no contamination or interference from the outside. But have rocks been closed for the millions of years that they've been sitting there in the ground? No. You've got groundwaters that flow through the rocks. Groundwaters leach uranium. They can add lead to the system. They can do all sorts of things. And so you can't be sure that your rock hasn't been contaminated through all the time it's been sitting there in the ground. And what about the radioactive decay rate? Can we be sure that the rate we measure today has been constant through time? Actually, we've only been measuring the rates for the last 80 years in the lab, and even then, if you do the investigations, we've discovered that there's inconsistencies, that some of the measurements by whatever techniques they've used haven't always replicated results that other laboratories have produced. And the interesting thing, as a side note, the way the geochronology community gets around that is they calibrate all the radiometric clocks against uranium lead. So the decay rate of potassium is actually calibrated to the decay rate of uranium, so that the methods are not independent of one another. Their decay rates have been calibrated against one another, which is an issue that I've been looking into recently, and also been looking into how well we really do know the uranium decay rate, and also is the method as good as it's claimed to be. But that's another story. So that's our third assumption. Now, none of these assumptions are provable. Why? Because the past cannot be observed and measured. We can't test the past. We can only test the present. Yes, things did exist in the past, and what happened in the past has produced what we see today, but our assumptions about how today was produced will determine how good we are at figuring out what happened in the past. So, and I would add that these assumptions are not even reasonable simply because we know that contamination is common. We know the possibility that the system may not have started with zero daughters in the rock. And in fact, we can show that all of these assumptions have been violated. We have evidence, and come back for our extended talk on radiometric dating, and I'll show you the evidence that these assumptions have been violated. And if the assumptions have been violated, then the clocks don't give reliable ages, absolute ages, that is. So we know that daughter atoms are regularly inherited when a rock forms, so the initial conditions are not known. Subsequent contamination is common, so it hasn't been a closed system, and decay rates were likely very much faster in the past. So if we don't have a constant decay rate, we don't have a closed system, and we don't know the initial conditions, then these clocks aren't really good timepieces at all. But as I'll show you tomorrow, we can still use them in a relative sense if we know something about these various assumptions, and we'll come back to that. I just want to give you one example before we close off in this session. And we go to the Grand Canyon. You'll notice that we geologists talk a lot about the Grand Canyon, not because we're necessarily Americocentric, but simply because this is one of the best places on Earth where much of the geological record is exposed to view. You can actually walk from the bottom of the Grand Canyon to the top and beyond, and you're climbing your way through the record of Earth history. And that's what makes the Grand Canyon such a unique place and an important place to test the creation flood model. And so in the Grand Canyon, and this is work that Dr. Austin has been involved in heavily, there's lava flows that are so recent we can still see some of the volcanoes on the north rim of the canyon, and the lava flows spill down on the walls of the canyon and they block the Colorado River. So it was after the canyon formed. So this is post-flood, after the flood. Then we also have, here they are, here's one of these volcanoes. That's Vulcan's Throne, and here you can see the lava flows spilled over the walls of the canyon. We also have lava flows down the bottom of the canyon. These are the Cardenas basalts. These are the inner gorge, and I'll say something more about these rocks on Thursday. These are pre-flood rocks. These are ancient rocks in anyone's terminology. And so there's these two basalts that we can contrast. What do the radiometric methods show about the ages of these rocks? What sort of results we get? Oh, here's the Cardenas basalts looking down over the rim of the canyon, and here they are up close and personal when Dr. Austin went in and sampled some of these for dating work. Well, the Eureka Plateau basalts, these ones that are so recent, they give you a variety of ages, from potassium argon, which are young ages, all the way up to older ages with the rubidium, strontium, lead dating. And I'm assuming you understand the chemical symbols there. Potassium argon, rubidium, strontium, lead. That's the two end members of the two uranium parents, uranium-238 and uranium-235. Notice that there's a disparity in the ages. Which one of these is the correct age for the rock? Well, if you weren't there to see the eruptions, you couldn't be sure, but you'd probably posit that this is a reasonable estimate because we know it's so recent that it came down the walls of the canyon. What about the Cardenas basalts? The same samples with all of these methods. Notice the potassium argon, rubidium, strontium, samaridium. The samaridium is 3 times the size of the potassium argon age. That's not very accurate, is it? That's incredibly different. What can we say? Well, look at these two lava flows See how similar their rubidium-strontium ages are? And by the way, this is using the superior isochron technique, which involves multiple samples to obtain the age, not single sample ages. These are multiple samples. So these are very good, with very good statistics. Notice that the rubidium-strontium isochron ages are very similar within the error margins. Why do you think that these two lavas would give you a similar rubidium-strontium age? Well, it would be if they have a similar rubidium-strontium chemistry, which would go back to their source. Basalts come from the upper mantle. The upper mantle below the Grand Canyon would have been the source for both the ancient and the recent lava flows. So if they came from the same mantle source, they would have the same mantle rubidium-strontium chemistry, which would give you the same age. So in other words, these ages really aren't true ages. They're a result of the chemistry of the source. Look at the differences in these ages. Notice that there's a pattern. You can see the recent lava flows here and the Cardenas, the ancient ones. Notice that the potassium is always the youngest. The rubidium is next, and these ones are older in both of these situations. In other words, there's a systematic pattern which indicates that there's a systematic process going on. And it's best explained by rapid acceleration of decay rates in some catastrophic event in the past. And so, as I'll be at pains to point out tomorrow, in the case of the Cardenas basalt, what we're saying is during a past catastrophic event. No, let me just back up here and preface this by reminding you. If you go to the literature, each one of these methods would be like having several hourglass clocks lined up on the bench here. And each would have different sized sand grains, different sized nuclei of the parent atoms, and therefore they would produce different daughters, green atoms. But all clocks should tick through 1 hour, through the same 1 hour real-time period. They should give you the same age. That's why we argued that each of these clocks, if we applied all the methods to each of these rocks, we should get the same results through the same real-time period, from the formation of the rock to the day. So in the real-time period from when the Cardenas basalt formed to the day, which is the time period since the rock formed, what's happened is, on the assumption of present-day decay rates, the rubidium-strontium clock has ticked through 516 million years, while the potassium-argon, while the rubidium-strontium has ticked through 1,111 million years, while the samarium has ticked through 1,588 million years. In other words, the decay rates, the only way you can reconcile that disparity is if the decay rates were happening more rapidly in the past compared to the rates that we measure today. So I don't have time to go into that in more detail because I want to wrap this up. But let's give the lessons here in summary. The recent erupted basalts inherited their ages from their source, so we can be sure that the ancient basalt also inherited the same isotope chemistry. The initial conditions were not known. We cannot be sure a contamination has not occurred. It has not been a closed system, and the decay rates were not constant in the past. So, in closing on the scientific side of the equation, let me remind you again, all scientific evidence involves and requires unprovable assumptions. We choose a rate that we measure in the present. We start with suitable and reasonable starting conditions that we assume, but we can't prove them because we weren't there to see those initial conditions at the start. If we assume the rate has been constant in the time, although that no scientists were there to check that the rates have been constant through time, then these processes, even radiometric dating, can only give us a maximum qualitative maximum age for the Earth. So the question is, how then can we be sure of the Earth's age, its true age? Well, the answer is only if we have an eyewitness who was present, who's given us a reliable eyewitness record of what happened in the past. And as Christians, we say, yes, we do have that. In the Scriptures, we have the Creator's record of what happened. He's told us when the earth was formed, how it was formed, and what's happened since at the time of the flood. And so we know about the earth's age and its history from an eyewitness who was reliable, because God cannot lie. And Jesus, the Creator, said, and I like to remind Christians who struggle with this issue, if you say you're a Christ follower, then what did Jesus say? I am the way, the truth, and the life. No one comes to the Father except through me. That means that Jesus never told us a lie, otherwise he is not the way, and he's not the truth, and he's not the life. And Jesus said, if you believe not Moses, you would have believed, if you had believed Moses, you would have believed me, for he wrote of me. But if you believe not his writings, how will you believe my words? Moses wrote about creation and the flood in Genesis. So Jesus is saying, if we don't believe what Moses told us, then how are we going to believe what he's telling us? And Jesus himself taught. He said from the beginning of the creation which God created. In other words, Jesus believed and taught that there was a beginning and that God created all things. And furthermore, he said from the beginning of the creation, God made them male and female. So Jesus was teaching that God made man at the beginning of time, as recorded in Genesis, not after billions of years of cosmic, geologic and biologic. Man was made at the beginning of time. That's the secular conventional paradigm. Man is not at the beginning. He's way here at the trailing edge of the present trailing edge of time. The beginning of creation was back here 13.8 billion years ago at the Big Bang. Whereas Jesus' timeline is no. From the beginning of the creation, God made them male and female. Looking back from today, man created on day 6 is way back there at the beginning of the creation. That's consistently what Jesus is teaching, just as we read in Genesis. So here's the question. When it comes to the earth's age, why does this matter? Well, it matters because as Christians, why should we give precedence to the conventional paradigm over the clear God-breathed statements of Scripture when that conventional paradigm has been framed by scientists interpreting what they see without reference to, in fact, they reject God's word. These are finite, fallible scientists who reject God's word. Why should we try and tack on their interpretations to what God has clearly told us in his words? Yes, human reasoning alone insists that today's natural processes are the only scientific means for calculating the age of the earth. Dr. Tackett referred to that in the opening session, only thinking inside the box. We as Christians, we look outside the box to the Creator who exists outside the box. And so we have a different way of looking at things. Remember, therefore, all human activities, including science, should humbly submit to the Word of God. Yes, science does provide answers confirming the Earth's real age, and we went through some of those evidences earlier in the session, but we can only find the Earth's real age plainly evident in the light of the authorities of God's Word beginning in Genesis. So the literal historic record and the chronology in the Scriptures matter. Why? Because they are the chronology of God's plan of redemption and the genealogy of Jesus Christ, our Redeemer. The Scriptures are his story. They revolve around Jesus, the Creator, who came as a man to be our kinsman Redeemer and will eventually sum everything up when he comes again and ushers in a new heaven and a new earth. So it matters. That chronology matters because the chronology of Adam to the present, up to Christ, is his family history. And if he isn't our kinsman Redeemer, then he's not truly man who died on our behalf by his shed blood. So this is why this question ultimately matters. It's not just a scientific question, it's really a question about our eternal destiny, the truth of the central event of human history, the cross of Christ. Well, thank you very much for your attention.